This is Herbert Huber, and today we're going to do ZIMSEC Maths, the paper 1 question paper from June 2020. Yeah, so we're going to do that, and the first question, it says express 208.9 in standard form. So express 208.9 in standard form. So we have 208.9 and we need to express this to standard form or standard notation. So what is standard form? So standard form is this form: a by 10 to the power n, where a is any number equal to or greater than 1, but it has to be less than 10. So a is any number equal to or greater than 1, but less than 10. So we need to adjust this number. It means we have to adjust this number without changing the value of the number. We are just changing how we represent it. For example, someone can say 6 and someone can say half a dozen. There are two ways of representing the same number. So here what we do is we shift the comma. So we shift the comma here. The comma is between 8 and 9. We shift it 2 places. So 1, 2. So what we get is 2.089. So 2.089 times 10 to the power something. So compare those numbers. What you have is 208.9. It's a bigger number. You have made the number smaller. You have made the number smaller by making it 2.089. So in order for you to preserve that value, you have to power by a positive index. So by a positive power. And what integer do you put? You put the number of times that you shifted the comma to the left. So shifting the comma to the left, it means this one has to be positive. So positive what? Positive 2. So you get 2.089 times 10 to the power 2. So this is it. It means if you punch this in your calculator and you get it in normal form, you get 208.9. So we haven't changed the number, we just changed how we represent the number. So the second part says correct the same number to 3 significant figures. So you have question 1b, 208.9 to 3 significant figures, so 3SF. So here what you have to do is to identify the first significant figure, and first significant figure means the first non-zero number or digit. So identify the first non-zero digit first. The first non-zero digit is 1, so it's 2. So 2 is the first significant figure, 0, 2, the second significant figure, 8, the third significant figure. Here the guideline is 0 is significant because it's sandwiched between 2 significant figures. So that's also something to note. So you have 9 here. You look at the fourth significant figure and see how it affects the third significant figure. You just want 3 figures, so you have to round. So here 9, it's greater than 5. So if 9 is greater than 5, that means we have to round up this 8. So this 8 becomes 9. So you're done with this. And the other thing that I want you to note here is that these are 1 mark, so you only get a mark for the answer. So sometimes if you work out some of these maths and you work them out very quick, if you work out so many examples, what you do is you just know and you can just write the answer. But I advise you to follow the procedure that I did. And to the nearest 100, what you do is so you have 208 0.9, and now you want to correct it to the nearest 100. So it says 100 here. It doesn't say 100th or 100th. So it doesn't say this. It only says this, to the nearest 100. So identify what you do here is to identify the 100 decimal place. The 100 decimal place is this. So investigate how the next decimal place affects the 100 decimal place. So 0 doesn't affect 2. So it means we round down. So remember to put the placeholders. So these zeros, they are non-significant. So 100, it's 2. Then 200. So that's it, and you only get a mark for the answer. And now the second question says negative 10 to the power 0. This one is tricky. So 2a, it says negative 10 to the power 0. So here what they want you to understand is that this 0 doesn't affect this negative here. So this 0 doesn't affect this negative here. So the negative has to be preserved. And then 10 to the power 0, any number to the power 0, you get 1. Any number except for 1. Any number to the power 0, you get 1. So you get negative 1 overall. And just for contrast, this is different than if somebody gave you negative 10 to the power 0 like this. Why? Because these brackets, by virtue of this brackets, it means that this 0 now affects everything inside the bracket. So the 0 also affects the negative. So here would get positive 1. So this one is what you're supposed to get. This one is just for you to know what to look out for. If it's this, then it means negative is affected, but then negative was not affected for our case. So this next questions, the B part says 4 over 9 to the power 3 over 2. So 4 over 9 to the power 3 over 2. So the first thing that you do is to express this in square root power notation. So in square root power notation, this number is the numerator, so the numerator becomes the power. The denominator, this one is the denominator. The denominator becomes the root here. So you just put it, some people, they don't write 2 here. It doesn't matter, because square root simply means 2. So here you can put 2 if you want, or you can just not put 2, it's still okay. And square root of 4 of a fraction, it means square root of the numerator divided by square root of the denominator. So here our power is still there, but we're still solving what's inside the bracket. We'll first simplify the brackets first. So here square root of 4 means 2, and square root of 9 means 3. So to the power what? The power 3. And here 2 to the power 3, this power, it means it's affecting everything. It's affecting the numerator and the denominator separately. So here 2 to the power 3 is equal to 8. Remember, 2 to the power 3 means 2 times 2 times 2. So some of those stages, if you know, you can always skip them because they don't have any marks. So but then just for clarity, we are including this step. And 2 times 2 times 2, we get 8 by 3 times 3 times 3, we get what? 27. So the only reason I put this is so that you know that this 2 to the power 3, it's 2 times 2 times 2. Because some students, they fail here, they can put 6, they think it's 2 by 3, but it's not, it's 2 times 2 times 2. That's what 2 to the power 3 means. So this one would be your answer. Okay, so the second question is done. The third question says the Venn diagram shows 3 sets A, B, and C. their respective elements. So here it simply means A, the elements that you see in A, there they belong to A. The elements that you see in B, they belong to B. In C, they belong to C. But sometimes the elements, the sets, they share. So the subsets are the sets in the universal set, they share these numbers. So when they share, this part, for example, it's A intersection B. So that's that happens to be our first question. So A intersection B. Intersection means where the, like, intersection between rods means where the rods meet. So where the sets meet, where set A meets set B. And it also says list all elements. So you know that you're just looking for elements, you're not looking for a number. So here A intersection B, you have A and B. Where they intersect, it's this part here. That's the intersection. This is A, this is B. The part that they share, the part where they intersect, it's here. So you put your these weird brackets, and then you put your semicolon and to separate your elements, and then that's it. And then here you have your 1 mark. And the second part, so A part 2. A part 2 says work out A union B complement intersection C. So A union B complement is what? C is what? So we're going to list the elements and then we are going to compare them. So A union B means where A and B unite. So A union B, they unite here. This whole thing here, they belong to, if they were to combine, if they were to unite, then they would take up all the space. So this is A union B. So all the elements, this one, they're A union B. But we want complement. This marker here, it's a complement. So it means any elements outside of A and B. So we get 11 and 13. And just be careful. Sometimes, Sometimes you may have to look also outside the set. Sometimes there may be some numbers here, so you have to include them. But then here it says A intersect union B complement. It's simply the elements that are outside of A. And then elements of C, they are 1, you have 4, 7, 11, 13. So you're looking for the part where they intersect. So you're looking for A union B complement intersection C, where these two intersect. It means, again, it means what elements these two have in common. So if you're comparing two sets, you start for intersection, you start with a set that you compare from the perspective of the set that has fewer elements. So we start with this. So you look at one element, the first element, it's 11. So 11, it's common. So that's why I put it here. So you look at the element, then you compare. Sometimes you may have to compare like 3 sets, it's still okay. Whatever is common, you have to put it here. So 13, then you compare, then you see 13 as well. Oh, it's included. So we have to put. So this one would be your answer. So yeah, and just so you know, the reason we didn't compare from the perspective of C is that C has so many, so you end up saying, okay, is 1 there, then you see it's not there, you go again to 4, it's unnecessary. The shortest path is to just take the set with this list number of elements, and then you compare. Is 11 there? Oh yeah, it's there. Is 13 there? Oh, it's there. Then you write. And now it says elements of A union, so 3B, it requires number of n. The small letter n, it means number of. So here it says list all elements. So the elements we're listing, you put the elements here like this. But then right now it says number of. It means that your answer should be just a number. It's not elements. So A union C. A union C means A uniting with C. So again, it means this part. This part is A union C. That's A uniting with C. If they were to unite, if they were to combine the elements, all these elements would be there. So you're not looking for the elements themselves. You want their number. How many are they? That's what it means. So 1, 2, 3, 4, 5, 6, 7. So your answer would be 7. So that's it for the third question. And let's move to the fourth question. Fourth question says, solve the inequality 2 minus y. So 2 minus y less than 3y minus 10. So you have one option here. You have to combine the variable. So this one is the variable, y is the variable. So you have to combine them. So you can either move this to this side, or you can move this to the other side. So I advise you to move in such a way that the variable is positive. So here I would move 3y is positive and it's bigger. So here you would move this one to the side here. So move this one to the side. And don't move this one to the side. It's okay, but then you introduce some complications for yourself. Yeah, so here you get 2, and then this one has to move to the other side as well. Every number owns the sign to its left. So 10, it's minus 10, like this. So when it moves to this side, this process is called transposition. When you transpose negative 10 to the side, it becomes positive. So here you get 12. 12 less than, this is 4y. So here you divide both sides by 4. You get 3. Here 12 divided by 4. So divide both sides by 4. You get 3 and you get y. So your answer should be y. Here the sign is important. If you shift the sign, you can lose marks. So you get 1 mark if you get it wrong this time at this stage. So this sign, it's pointing away from y. So it's pointing away from y. This is important. You can get it wrong at the last stage. So be careful. So you get y greater than 3. So y is greater than 3. And then for 4b, now you're asked the perfect square. The perfect square or y satisfies both. This, recognize this one is exactly as this one. So we can use what we had that time. So what we had that time was y greater than 3. So this is what we had. So we want to combine it. So union y less than or equal to 9. So how do you combine? Just this one, just put it as it is, 9. And then this one, c, y, this inequality, it's pointing away from 3. So you put it like this. That's how you combine. So put this one first, or if you can even put this one first, it's still okay. But then the other one, investigate carefully how the other sign looks. And in almost all cases that I've dealt with, these inequality signs will be they will be pointing to one direction. So after this, now you need the perfect square y that satisfies. So you need the perfect square. So there are some elements, some numbers that represent y greater than 3 but less than 10. So the numbers are, the set for this, it's greater than 3, so it means 3 is not included. So it can be 4, it can be 5, it can be 6, it can be 7, it can be 8, and also it can be 9. So all these are possible values of y. But then we are told that y, it's a perfect square. It's a perfect square. So y must be equal to, now you select which one is a perfect square there. It's 4 or 9. So 4 is in 2 to the power 2, and 9 is in 3 to the power 3. These are perfect squares. Perfect squares are numbers with perfect square roots. So that's it for this question. And So let's move to question 5. Question 5 says solve the simultaneous equation. So you have 4 methods of solving simultaneous equations. So the four methods are: method 1, elimination; method 2, it's substitution; method 3, it's graphical analysis; method 4, it's matrix method. And the thing that you have to note about these methods is that they all get you the same answer. They all give the same answer. And normally the examiner, the exam, it doesn't say use this method or this method. So the order that I want you to, the order of preference in terms of working, because the writing exam, it's not only about knowing, but it's also about being strategic, being very, very fast in computing your answers. So the first, the order in which I want you to work this out is, where it's possible, use elimination method. It usually computes the answer the fastest. And when that's not possible for you, use substitution. Graphical analysis and matrix method, only use them when it's stated. When they require you to use graphical analysis or matrix method, that's when you use them. But then you end up taking so much time if you use them for the question at hand. So we have 2x plus y equal to 4 and x minus y equal to minus 2. So make sure that your entities, they're aligned. So you have 2x and x, you have the coefficients here. You have the coefficients here of y, and you have the numbers here separately. So this is good. So the order in which this is written and the order in which this is written, this is good. So we can try to use elimination method. Elimination method, use it by, you first check, are the coefficients the same? So for x, the coefficients are different. But then for y, the coefficients are the same. So coefficient of y here, it's 1, coefficient of y here, it's 1. So you have positive here and you have negative. If you want to eliminate, after matching those coefficients, if you want to eliminate this, if the signs are different, you add. If the signs are the same, you subtract. So that's the guideline. So here we are supposed to add y because we want to eliminate y, and the signs are different, we add. So here you get 2x plus x, you get 3x. Then plus y plus minus y, you get 0 here. So 4 plus minus 2. So it's like 4 minus 2. So you get 2. And then x is equal to what? 2 over 3. Here you divide both sides by 3. So divide both sides by 3, you get this. But then your answer is not done. In simultaneous equations, you have to get 2 answers. You have to get the value of x and you have to get the value of y. So find the equation that's easiest to use. So this one is negative, so you have to shift y, or you have to divide by minus 1. This one is not what we want to use. So say from 2x plus y equal to 4. So we get this y equal to 4 minus, this one you're going to transpose it to the side. So 2x. So 4 minus 2 by x, which is 2 over 3. So it's 4 minus, here if you're multiplying by a scalar, what you do is that the scalar multiplies the numerator only, so you get 4 over 3, right? And here just use primary school methods. So here 4 over 1, here it's 4 over 3. So 1 into 3, that's 3. 3 times 12 times 4, you get 12. And 3 into 3, that's 1. 1 times 4, what do you get? You get 4. So your ultimate answer for y is 8 by 3. So here, yeah, so you have to conclude as well. So you say therefore, this is how you write therefore in maths. So therefore x equal to 2 by 3, y equal to 8 by 3. So like this, and you are done. So those were the first 5 questions, and in the next part we are going to look at the next 5 questions.